Right, welcome back. This is the second video dealing with this question from 2012, part C. And we're just going to jump into the question now. If you've already watched the first video, then you're well on the way. So the horizontal line y equals k divides that region into two regions of equal area. We talked in the first video about how we want to see this, how we want to picture this as having a defined left-hand side and a defined right-hand side. So we said the left-hand side, this line that I'm going over here in yellow, and the equation of that is y equals log x. Okay, and what we said in the previous video was when we're thinking about this in terms of horizontal rectangles, horizontal sections, we need to change that around and write the equation as a function of y rather than as a function of x. Instead of writing y as a function of x, write x as a function of y. And if y equals the log of x, and we change that around, then we would have x equals e to the y. So the left-hand curve, that's the left-hand curve. So we'll call it xl is equal to e to the power of y. And then we'll do something similar on the right-hand side. We know that this is the curve, sorry, it's a bit messy, but this is the line y equals 5 minus x. And if we rearrange that, bring the x over, move the y back, we get x equals 5 minus y, and this is the right-hand curve, so let's call it xr equals 5 minus y. Those are the same curves, they're just written in different formats. We usually write curves as functions of x. Now we're writing them as functions of y. It's very unusual, but in this case, it's very beneficial. So the next thing we're going to do here now is we're going to read the question again. Horizontal line y equals k divides r into two regions of equal area. So let's draw that. Let's blow this up a little bit and let's draw a line y equals k. Horizontal line y equals k. Okay, so all right. So this is the line y equals k. Okay. The red line is the line y equals k. Okay. So that would mean the y coordinate here, and that's going to be very important. The y coordinate here is k. Okay, that's actually going to be important that we realize that the line y equals k is at a height of k. Okay, so now what do we do? Well, we know that the region above this line, let's shade it in green. And this may not look very realistic, but that doesn't matter as long as the general idea is right. The important thing is that the region above the line y equals k, the area of that region is the same as the region below the line y equals k. Okay. So the green area has to be equal to the purple area. Okay. That's what the question said to do. It said to pick that line so that the area above it and below it are the same. Well, the green area, okay, the green area, instead of going from top to bottom, we're going to go from right to left. So again, this is all coming from the previous video. The area in green would be the integral of xr minus xl dy. Okay, now that region there in green, it begins in terms of going from the bottom to the top. The bottom of that region, the y coordinate of the lowest point in that region is k. Okay, so the green goes from k up to 1. Okay, so from k up to 1, that's the area in green. And what we're saying is that has to be equal to the purple area. Okay, and again, it's the same thing, xr minus XL dy. Now the purple area starts when y is 0. Okay, purple area starts when y is 0 and goes up to k. Okay, so we're basically there. The only thing we're going to do now to finish this is just to substitute for xr and xl. Okay, so we're going to substitute for xr and xl. We're going to go integral from k to 1. xr is 5 minus y minus xl is e to the y. dy is going to be equal to the integral. Same thing, going to be exactly the same thing, but the limits change. 0 to 1, 5 minus y minus e to the y dy. Okay, 5 minus y minus e to the y dy. Okay, so this is the approach, and that's it. By the way, that's the answer. Okay, that was what we had to do in this question. That was what we had to do in this entire question. So we had to write, but do not solve an equation involving one or more integrals. The solution gives the value of k. Okay, so if we were to solve that, we were to integrate both of those and plug in those numbers. Remember, all the y's would disappear because you're going to replace the y's with 1 and k and 0 and 1. So the only unknown you'd have left in there would be k. All right. So it's possible to solve that, and it's not terribly difficult, not terribly easy, but with a calculator you could certainly do it, but you don't need to do it. That's all the work you need to do. So what's all this about then? Well, just to summarize it, let's see if we can put it in words. If a region seems to be defined by a left-hand side, or a left side and a right side, rather than a top and a bottom, then the steps you would take would be A, change both equations to get x on its own. B, find the area from the integral from xr minus xl dy from the lowest y coordinate to the highest y coordinate. Okay. So there's two things really that you need to do, and I know we've spent quite a long time on this, but the two things you need to do. First thing is to change both equations to get x on its own, and then remember when the formula is xr minus xl, and that your coordinates, that your limits are the y coordinates of the top, of the lowest point and the highest point. Okay. Now let me just check something here. And if you look at a shortcut for area and volume, these are in your own notes, shortcut for area and volume between two curves, you can see that there's a further explanation of this over on the right hand panel. Okay, so this is in your notes again. It's done this way, but hopefully you'll find the video helpful as well. Okay, thanks again for watching, and hopefully this helps. Let me know if it doesn't. I'll try and help you.